Good afternoon, everyone. Scott Lowe back here again on vBrownbag Tech Talks. Really excited to have the opportunity to come back up again. So I'm going to take a few minutes and talk about a couple of technologies that you might think are a bit odd to talk about at a VMware conference. And so as you can see, if you can see the slides here, we're going to talk about the combination of Docker, Machine, and OpenStack. This is kind of a follow-on from some blogging that I did a couple weeks ago, maybe more than a few weeks ago, on using Docker Machine and OpenStack together. So, kind of set the stage for the rest of this talk real quick. Why am I talking about this? Well, earlier today, Alistair and I were talking on here about kind of the shift for IT professionals and what we need to do, moving out of being just pure infrastructure gals and guys to also looking at how the infrastructure that we set up and provide is also consumed. And thinking along those lines, you know, a couple of the technologies that are rather prevalent, at least in the open source communities, are OpenStack as a cloud orchestration platform and Docker Machine as a tool for helping simplify developer productivity. Now, OpenStack, of course, as you probably are aware, works great with VMware products. So you can run vSphere underneath OpenStack, you can run NSX under OpenStack, as I do. You could run vSAN underneath OpenStack, all this kind of stuff. So, there's a natural kind of evolution for a VMware professional to be able to look at these technologies as well, and see how there are ways to use them inside their predominantly VMware-based infrastructure. All right, so let's just jump right in, and we'll start just by talking about Docker. I don't think that I'll need to spend too much time here because most everyone in the world, unless you've been hiding under a rock, probably knows what this is and what it does. But just to make sure that we're on the same page, I just want to take a couple minutes and talk about it. Okay. So what is Docker? Docker is a CLI tool that simplifies the use of Linux containers. So it's a little important to understand that Docker itself is a form of Linux containers. It's not the only Linux container game out there. There's also LXC and LXD and some other pieces, but Docker is the one that most people associate with containers. When you wonder, okay, what are Linux containers? They're a form of OS virtualization. So the operating system base, the kernel, shared libraries, all of that are shared between all the containers. So we're not providing full virtual machines. We're providing basically a virtual user space, and then the rest of it is shared across multiple instances, which makes it a little more lightweight than perhaps a full machine virtualization solution like a traditional hypervisor. Now, naturally, because the kernel is kind of the piece that's doing this, there are certain kernel features that Linux containers require. Things like C groups, which are control groups, and things like namespaces, which allow us to isolate process tables and networking tables and other things, right? Docker itself is available as an open source project that you can download and install, and there's the URL. So, again, you probably know all this already, but I wanted to kind of set the stage for what we're talking about. Components of Docker, because Docker is a Linux-based technology, you have to have a Linux runtime host. So there has to be something running Linux, right, that will allow the Linux kernel, which provides the features Docker requires, to be present. So that's sort of a key difference from, let's say, a traditional Type 1 hypervisor, is that you have to have this Linux operating system installed, and then you can create containers that run on top of that operating system instance. Then you have the Docker daemon itself. You have a Docker client, which may be local to that same host, or it may be remote. For example, I could run the Docker client on my laptop and connect to the Docker daemon across the network, right? And then you'll need a Docker image, or you'll need what's known as a Docker file, which is a plain text file that describes how to build that image. And then together, what you can do is you can use the Docker client to communicate to the Docker daemon to tell it to take an image or a Docker file and build an image and create a container, right? But the key thing that Docker doesn't do by itself here is anything having to do with that Linux host. So it assumes that this Linux host is already there and that the necessary software is already installed. So that's where Docker Machine comes in, right? Docker Machine is a tool to kind of help with that process. And I got so excited about coming up here that I forgot. I'm gonna kick off something real quick because it's gonna take a few minutes to run in the back end. So I'm gonna come back to Docker Machine in just a moment. But first I'm going to come over here, and what I have over here is I'm just logged into a system in my lab, and we have a command that I'm going to run. Okay. Nope, I've lost my connection. We may have to skip that. Okay. All right, that's fine. We may not do the live demo because, well, that's how live demos work. If I can get back in, I'll show you a few commands. But let's talk about Docker Machine real quick, all right? So what is Docker Machine exactly? So Docker, the company, after working on Docker, the open source project, and realizing that none of their stuff really did anything to help with provisioning that Linux runtime host that is required, came up with Docker Machine. And the idea behind Docker Machine is that as a developer, I may not have any sort of easy way of spinning up this Linux runtime, this Linux container, this Linux host that I need. So what if Docker could provide a mechanism that would make it easier for a developer to say, give me that Linux host that I need, and have it pre-provisioned and pre-configured with Docker so that I can just begin to consume it with Docker images, right? So it's designed to work with multiple backend drivers. The idea being that this is one interface, and then you could use the Docker machine to interact, for example, with vSphere, or interact with VMware Fusion on your local laptop, or App Catalyst, for example, which is the new kind of developer-focused desktop virtualization product. But there are also some other drivers, and there's a couple in particular that I want to mention. One of these is called the generic driver. The generic driver is then intended to consume existing VMs. So if you have VMs out in your infrastructure and you say, hey, maybe I'm the virtualization admin and you want to make it accessible to a developer to be consumed for Docker, you can provision the VM, give that developer the IP address and the login, and say, here, you can go do that. Now, they don't need any other information, just a base Linux installation. Then using the generic driver, they can then take that VM and basically prepare it for use with Docker. So Docker Machine will attach to that system, it'll log in, it'll install the Docker daemon, configure it for use across the network, which is as a non-default configuration. By default, out of the box, it doesn't listen across the network, right? Configures it to listen across the network. Well, it's TLS secured, so there's transport level security, and then makes you ready. And then at that point, you can begin to run your Docker commands, and off you go, right? But the other, that's cool, and it's interesting, it's neat. But kind of more interesting and more fascinating to me is this idea behind being able to provision and prepare new VMs using these other drivers. And one of these other drivers is a driver for OpenStack, right? And so the idea behind the OpenStack driver for Docker Machine is that developers could actually provision VMs, instances as we call them in the OpenStack world, provision instances, right, automatically from their own laptop, right, and then have those instances prepared with the Docker daemon, pre-configured, pre-installed, ready to go, so that for them it's something they can just go in here, they type in a few commands, it provisions a VM automatically for them, it installs Docker onto that VM, it configures it to talk across the network, and then they're off to go, pulling down images, creating new images, building Docker files, the things that they want to be able to get on with, right? It doesn't slow them down. They're able to consume the infrastructure that we, as infrastructure admins, are building more easily. So let's talk a little bit about OpenStack, right? OpenStack, as you may or may not know, it's an open source framework of projects for cloud management. OpenStack itself is not a hypervisor, for example. It requires a hypervisor to run, so you're going to have to leverage something like a vSphere or perhaps a KVM or even Hyper-V underneath it, right? It's designed to orchestrate and automate different types of infrastructure, so it's designed to work with a variety of hypervisors, designed to work with a variety of networking solutions and different storage platforms. And as I mentioned earlier in the presentation, it's certainly very, very possible to take a pure VMware infrastructure and make that ready to consume via OpenStack. You can plug in vSphere as a compute platform, you can plug in vSAN as a storage platform, you can plug in NSX as a networking platform, consume all that with OpenStack, just as you would if you were consuming a completely open source sort of environment, right? And one of the things that people like about OpenStack is that there's a set of RESTful APIs that can be relatively easily consumed from other products, and that makes integration with OpenStack perhaps a tad easier than integration with some other products. And so tools like Docker Machine via the OpenStack driver can then be built to consume the resources that are provided by OpenStack, right? So let's look at this. We could have a completely VMware-based infrastructure running vSphere, vSAN, NSX, or whatever collection of products that you've got out there. We could layer OpenStack on top of that, right? this gives people the ability to leverage those APIs to consume the infrastructure using tools that you're already using, and you can continue to use, the whole vRealize suite to manage and optimize the infrastructure. But then the developers get a really seamless sort of environment, a really seamless way of being able to say, hey, I need to consume some of that infrastructure to get my job done. So I'm going to go run Docker machine, provision an instance, put the Docker daemon on it, and then I'm off to the races. So this is kind of the summary of what I've just been talking about, and that is it builds what I like to call a provider-consumer relationship, right? IT becomes basically a service provider. We are providing infrastructure services to a consumer, and the consumer in this case may be internal to our organization, but they are a developer or a development team or a line of business that needs to consume that infrastructure. So we become the provider, and we're providing a service, and then they become the consumer, and they're consuming that service, and they're doing so in a way that kind of fits in with what they're doing already. Docker, one of the key things, if you go look at Solomon Hykes and the guys at Docker, one of the key things they're always shooting to maintain is the developer workflow. They want it to be really clean, really straightforward, right, to work well for the developer. So this gives you the ability to interact in a tool that's been streamlined for development use, but continue to consume the same sort of infrastructure that you've gotten used to consuming. So maybe demo time, we don't know yet. We'll find out here in just a second whether my connection is live or not. Oh, see now right there it's dead. So let's log back in again. Maybe. No. Oh, okay, there we go. All right, so now we're back in again. I'm going to just run Docker machine here. All right, and I'll kick off the process of provisioning a new instance in just a moment. It takes a few minutes, and it's boring, and you'll just sit there and watch minutes of dead time on the video. So we won't wait for it to finish, but just to show you that we have this present, I've already provisioned one. You can see it's called TechTalk01. It's using the OpenStack driver, and it's available there. And if I just run this command real quick, what I just did right there is I told the shell, the place where I'm logged in, that I want to look at, I want Docker machine to tell me the sort of variables that I need for Docker to connect to machine across the network, right? And so now I can just run the straight up Docker client, and I can run things like, Docker PS, show me the containers that are running. There are no containers running right now because I just spun this instance up, so there you go. But I could also look at the Docker images that might be present. And again, there are no Docker images, but if there were, they would be listed here, right? Now, the idea behind, I'm going to run a few more commands here real quick. This is an OpenStack command. You'll notice that we have this Docker machine instance listed as TechTalk01 here. I'm going to show you that on the back end there is a matching. Got to run another command first here. There we go. There's a matching OpenStack instance, so you can see I have an OpenStack instance named TechTalk01, and you can see if you look at the IP addresses here, 172.16.5.112 is shown by Docker machine, which corresponds to the floating IP that was assigned by OpenStack, and all that was done automatically. So if I just look and see if I can, okay, I don't have the command in my history here. So I won't bother running it because it's a really long command, but basically I could use the Docker machine command here to actually create an entirely new instance. And I wouldn't have to log into OpenStack to do that. I could just use the information that I have already here on the command line, which means it can be scripted, it can be automated, and be made very seamless for the developer, right? And so again, the core goal here is to say, what are the ways that we as infrastructure providers can continue to provide infrastructure in a way that makes sense for us, right? To be managed and optimized and used very efficiently, but be able to be consumed by ways that make sense to those who are consuming it, right? So that's sort of the live demo. Abbreviated due to the earlier connectivity issues, but you get the idea. And if you want to see what it looks like, I'm here at VMworld all week, and I'll be happy to catch up with you, show you live what it looks like and how it works. So if you want to follow up on any of the resources, I did blog about this, so if you visit my site at blog.scottlowe.org, you'll find an article that has more information. You can hit me on Twitter if you'd like. I do have a GitHub account, and I have a repo there that has files to help you do this on your own. So you could use Vagrant and VMware Fusion or Vagrant and OpenStack to spin up this sort of environment, to test it yourself, just to get a feel for how it works and what sort of files will be required. So that's it for me. Back to you guys.